In this video we will show you how you can do the double slit experiment with photons at home, using nothing else than cheap everyday stuff. For that, you need a laser pointer like those you might have used in school presentations or office talks. It's sufficient to take the cheapest one that you find. The only thing that matters is to have a thin, nearly monochromatic light beam. Of course, do not use an advanced laser with a large enough power to damage your eyes. The second thing that you need is an object with thin slits that are separated by only a few micrometers, for example a DVD, but take one you won't use anymore. The rainbow colors that you see on the reflective layers of DVDs originate from a dispersive diffraction of daylight by the pits used to store the data. We will use these pits as a multi-slit. The relative sizes of the slits, their separation, the light wavelength, which is typically a few hundred nanometers, and the distance to the screen are the whole trick behind making the interference pattern visible to the eye. We begin by separating the DVD layers. This is done easiest if you start by cutting it at the border. If you damage the DVD sufficiently, you should be able to see the two layers more clearly and to separate them more easily. We only need the transparent parts. Now we're ready. Point the laser through the DVD layer, but be careful with the reflected beams. For your own safety, place a sheet between you and the DVD such that you don't see the DVD, but only the dot that is created by the resulting laser beam on the screen. Alright, that looks good. Now let's switch off the light. At first it might be hard to find the interference pattern and to keep it when trying to improve it. Try slightly different angles of incidence and different locations on the DVD. Alright, this looks perfect. You can see many of the minor maxima. As already mentioned, this is not only a double but a multi-slit experiment. It demonstrates the wave-like nature of photons by visualizing how different parts of the quantum mechanical wave functions interfere behind this array of DVD pits. Any classical explanation can be ruled out when this experiment is done with single photons instead of a whole beam. Of course, this requires special lasers. Thank you very much for watching.